March 1916. A British officer stands in a communication trench near Verdun, his Webley Fosbury automatic revolver holstered at his hip. He turns sharply to move along the trench wall. The holster strikes the rough timber revetment. The weapon discharges. The bullet exits through the bottom of the leather holster and enters the officer's thigh at a downward angle, missing the femoral artery by approximately 3 centimeters. He survives, but loses the leg below the knee. The weapon that fired was not defective in the conventional sense. It functioned exactly as designed. The problem was that its design allowed firing without trigger manipulation under specific mechanical conditions that occurred frequently in combat environments. The Webley Fosbury was one of several early semi-automatic and automatic pistol designs adopted during World War I that shared a critical flaw: inadequate drop safety mechanisms and external hammers or strikers that could be activated by impact. Between 1914 and 1918, accidental discharges from these weapons caused hundreds of casualties among forces that issued them, leading to rapid withdrawal from service or extensive modifications that often compromised the weapon's functionality. Military forces in the early 20th century faced a transition problem from revolvers to semi-automatic pistols. That was mechanical and doctrinal. The development of self-loading pistols promised increased ammunition capacity and faster reloading, advantages that mattered in close-quarters combat. But early semi-automatic designs prioritized mechanical reliability and rate of fire over safety mechanisms. Most featured external hammers that could be struck accidentally, exposed firing pins that could be driven forward by impact, or trigger mechanisms without adequate disconnectors to prevent firing unless the trigger was deliberately pulled. Safety mechanisms, when present, were often manual levers that soldiers forgot to engage or that disengaged accidentally during carrying or movement. The result was a generation of weapons that fired unexpectedly when dropped, struck, or subjected to the routine physical stresses of combat operations. The Webley Fosbury represented an attempt to combine revolver reliability with semi-automatic convenience. Adopted in limited numbers by British forces beginning in 1901, it used recoil energy to rotate the cylinder and cock the hammer automatically after each shot. The upper frame, including barrel and cylinder, recoiled backward along grooves in the lower frame. Zigzag grooves cut into the cylinder and gauged a stud, rotating the cylinder one position during recoil. A cam cocked the hammer during the same rearward movement. When the trigger was pulled and the weapon fired, recoil automated functions that required manual operation in conventional revolvers. The mechanism was ingenious, but it contained a fundamental safety flaw. The hammer could be knocked backward by external impact, and if the cylinder was properly aligned, the hammer would strike the firing pin and discharge the weapon without trigger involvement. The weapon weighed approximately 1.1 kilograms, loaded with 6.455 Webley rounds. Muzzle velocity was about 180 meters per second, lower than contemporary revolvers because energy was diverted to cycling the mechanism. The automatic cycling worked reliably only with full-power ammunition, which produced substantial recoil and degraded accuracy in rapid fire. The exposed hammer protruded significantly, making it vulnerable to snagging on equipment or striking objects during movement. The lack of a hammer block or transfer bar safety meant that any rearward movement of the hammer that reached the cocking position could release and strike the firing pin, even if the trigger was not engaged. This occurred most commonly when the weapon was dropped hammer down onto a hard surface, or when a holstered weapon struck objects forcefully. Early semi-automatic pistols from other manufacturers exhibited similar problems through different mechanisms. The Colt M1911, adopted by the United States in 1911, featured a grip safety and thumb safety, but could still discharge if dropped at specific angles that disengaged the grip safety through inertia, while the hammer struck the firing pin. The German Luger P08, generally safe when carried with an empty chamber, could discharge if carried chambered and subjected to severe impact. Various pocket automatics manufactured by FN and Mauser lacked drop safeties entirely, relying on trigger pull weight as the sole prevention against accidental discharge. Combat conditions proved that this was inadequate. Soldiers climbed obstacles, moved through debris, fell during artillery bombardment, and engaged in hand-to-hand combat, all of which created opportunities for weapons to be struck, dropped, or subjected to forces that bypassed inadequate safety systems. Documented cases of accidental discharges accumulated rapidly. British Army medical records from 1915 and 1916 note multiple instances of officers wounded by their own Webley-Fosbury revolvers discharging in holsters. American Expeditionary Force reports from 1918 document M1911 pistols discharging when dropped during training, leading to revised carrying procedures requiring empty chambers, defeating the weapon's readiness advantage. French forces using various automatics reported similar incidents, frequently enough to prompt formal investigations into weapon safety. The mechanical cause was well understood but poorly addressed. Effective drop safety required a physical interlock, preventing firing pin movement unless the trigger was pulled fully. This could be achieved with firing pin blocks or hammer blocks, but both added complexity and manufacturing cost. Many early designs omitted them or implemented them inadequately. The Webley-Fosbury had neither. The M1911's grip safety could be bypassed by inertia. The Luger offered partial protection, but not in all scenarios. Testing protocols were insufficient. Proof testing focused on pressure and barrel strength, not impact safety. Drop testing was not standardized and rarely reflected real combat conditions. Weapons passed acceptance only to reveal flaws after field deployment. Once adopted, design changes were difficult, requiring retooling, production interruptions, and logistical complications, often deemed impractical during wartime. Comparison with other designs shows the problem was widespread. The Russian Nagant M1895 revolver with an enclosed hammer was effectively immune to accidental discharge, but lacked capacity and reload speed. The German C96 Mauser, with its internal hammer and heavy trigger pull, was relatively safe, but expensive and complex. The Colt N1911, despite flaws, was among the safer designs of its era. The unresolved tension was between simplicity for reliability and complexity for safety. Early semi-automatic pistols failed to balance the two. Field solutions arrived faster than design fixes. British forces withdrew the Webley-Fosbury by mid-1916, citing accidental discharges and sensitivity to mud. Officers reverted to standard Webley revolvers, sacrificing automation for safety. American forces mandated empty chamber carry, increasing reaction time to the first shot. Other armies prohibited cocked hammer carry, requiring manual cocking. These measures reduced accidents but erased much of the advantage that semi-automatics promised. The long-term consequence was accelerated safety development. Post-war designs like the Browning High Power included firing pin blocks as standard. Military procurement began requiring drop testing from multiple angles and heights. World War I's accidents forced recognition that lethality without control was unacceptable. The true number of accidental discharges is difficult to determine. Many were recorded as training accidents or self-inflicted wounds scattered across records. Conservative estimates suggest several hundred Allied personnel were wounded this way. The true figure was likely higher. Some incidents may have been misreported to avoid disciplinary consequences or due to genuine uncertainty. The British officer who lost his leg in March 1916 was one of dozens injured by the Webley Fosbury before its withdrawal. His wound was recorded as a combat injury, obscuring the frequency of such accidents. The weapon fired without trigger manipulation, not due to defect, but because its design allowed it. These early semi-automatic pistols were not anomalies. They represented an era before militaries understood that a weapon is deadly to the enemy, must not be equally dangerous to the soldier carrying it.